I'll share my screen. Can you guys see my screen? All right. Thank you for the introduction. Today I will be talking about unlocking the power of open source in machine learning. My name is Ahmad Anis, and currently I'm working as a deep learning engineer at Roll.ai. It's a startup based off San Francisco, and we work on AI video editing. I'm also a community lead at Cohere for AI, which is an open science initiative for changing how the research is done in the space of AI. I also have 2600 plus points on Stack Overflow and have contributed to several open source repos. I have also written several articles for KD Nuggets towards data science and other famous blogs. So before talking more about how we can do open source in ML, I'll talk a little bit about how it is different from traditional open source. So the traditional open source, which is mostly in the field of software engineering, it is different from the open source contribution that you need to do in machine learning. So traditionally, in software engineering, it is very code centric. So for example, if you find an open source repo, you see a problem such as there is something in UI that needs to be fixed. You go to the code, you fix that UI, or you see some error in the database or in the backend side. You go to the code, you create a pull request, and you contribute to that repo. But in machine learning, it is not always this uh, contributing to code or very code centric open source. There is some different types of paradigms in open source machine learning. So, for example, you can share some pre-trained models that you have trained. You can share new architecture. You can share new data set. You can share new project technique, new optimization techniques, or you can share uh, uh, how you have written a new model. So overall, the essence of open source is same in both traditional open source and open source in machine learning. But there are more ways to contribute in open source in machine learning as compared to the typical open source software engineering paradigm. And then there's one thing that is common in both, that is you can create new projects and you can push those projects towards open source repo. Now, I'll talk a little bit about what are some of the famous machine learning libraries. So, you can see that there is TensorFlow, which has 186,000 stars, which is one of the highest starred library in GitHub. Then there is PyTorch with 83,000 stars. Then Hugging Face Transformers with 120k stars. Hugging Face datasets has 19k stars. LangChain, which is a relatively new framework for creating RAG application, it has 58k stars. Llama Index has 16k stars, and Scikit-learn has 59.8k stars. And there are several other machine learning repos you can find on GitHub, which are highly famous and have a lot of stars. So you can see what are the libraries that are relatively in these days. But it is not equally easy to contribute to all of these libraries. So, for example, if you want to contribute to TensorFlow or PyTorch, it is really difficult because these are some of the frameworks that are written in low-level languages, and these are it requires a lot of underlying knowledge. So it is not always easy to contribute to a framework like TensorFlow or PyTorch. But if you talk about Hugging Face transformers or Hugging Face datasets, these are some of the libraries in which the contribution difficulty uh, is not as high as TensorFlow or Python. So you can contribute to their code bases with a relatively normal knowledge of the code base. Then if we talk about LangChain and Llama Index, these are totally based off Python and they are a very attractive libraries. So the contribution to these libraries is relatively easy. And similarly, there is scikit-learn, which is also a little difficult. And as a framework establishes more, the older it is, the difficult it gets to contribute to that framework, because it has a lot of knowledge or underlying knowledge of framework that you need to have before contribution. And the reason it is difficult to contribute to these famous frameworks is that because these frameworks are mostly written in low-level languages. So for example, TensorFlow is written in C, PyTorch was originally written in Lua, and now it is written in C and a bunch of other languages. And these frameworks act as a compiler. So they are so they convert your code from a high-level language, which is Python, and convert it to a lower level language such as C. And you also need to have good knowledge of CUDA, because these frameworks highly utilize GPUs, and all of majority of that GPU work is done in CUDA, which is in C. And then you also need to have a strong knowledge of OS, because you need to play around with a lot of operating system concepts, uh, so that you can contribute to these frameworks. So this is an example of a pull request that was in TensorFlow, and you can see here that the work here is done in C language. So it is not always that simple to contribute to these famous frameworks. But the goal of today's talk is that after this talk, I want that most of you should be able to contribute something to open source space in machine learning. So I'll talk more about how, as a beginner, you can do open source contribution, and then how you can take it to another level, how you can level up your contributions and contribute to bigger projects. So if I create a small framework for an open source contribution for a beginner, it would be a 4-step process. So the first step would be you need to, and this is more focused on how to create a project uh, and how to publish that project. So the first step would be that you need to find existing open source models or frameworks and understand them. So for example, you see that there is a model named Polygamma on GitHub or on Hugging Face. You need to play around with that model. You need to see what are the strong points of that model. You need to see that what are the shortcomings of that model. You need to understand how that model works. So you can read the research paper of that model, or you can read the blog. But the overall idea is that you need to get a hands-on practice on that model, and you need to find that what are the things that this model can do and what are the things that this model cannot do. Then you need to think about any problem that you would like to solve with this model, and ideally it should be a problem that these models cannot solve, or ideally it should be a problem that has not been solved already. So for example, with Polygamma, you see that you test the model and you found that this model cannot detect uh, cars in Pakistan. So the model can generally detect cars, but it cannot detect cars in Pakistan. It's just an example, or maybe some other thing. So you need to play around with that model, and you need to find what this model can do and what this model cannot do. So it can be any problem, from a small problem or a basic problem to a big problem. And then you need to see that do you need data for fine tuning that model, or can you use the zero shot capabilities of that model? So for example, you try to work with Polygamma and you see that the model actually can detect objects. And if the model is good at detecting objects, can you create a new data set from that model? So, or if you need to manually collect the data set for fine tuning. So the next step would be that you would be creating data set that you would be using to fine tune the model. Or you can also use the zero shot capabilities of models. Since these models are really strong, you might not need to fine tune these models. And the next step would be to publish your results. So you need to uh, publish your code to GitHub. A very good way to contribute is that you should write an article about all these steps of on what was the problem, what you did, how you solved it, and what is the current results of these problem now. So you write a good article on Medium, and then you also push your model and dataset to Hugging Face. And Hugging Face is really important these days. It is almost as important as creating a good GitHub profile. So creating a good GitHub profile is important in open source, but in ML you also need to have a good Hugging Face profile, because Hugging Face is the hub of all the models. So every major company releases their model on Hugging Face, and it is the easiest way to use all these models. So I'll just show you an all right. So these are some other ways on how you can contribute to open source as beginner. So most of the repos, not all of them, but a lot of the repos have an issue labeled as good first issue. So you can go to the issues of any repo, you can find good first issue, and these good first issues are generally targeted towards beginners because so the idea of good first issue is that anyone with relatively less knowledge of that framework should be able to solve that issue. So it is like a good first issue for a new person. But as a beginner, you can also improve the documentation. Most of these frameworks do not focus a lot on documentation. A lot of things are not clear, so you can work on improving the documentation. You can work on improving the error messages. You can also write a blog post on how to solve a task from a complex framework. So, for example, you can write a blog post on how to use TensorFlow to detect household objects or something like that. And then you can contribute on Stack Overflow on answering questions and answers. So in any way you can contribute to the open source community as a beginner, you should do it. So I'll just show you a coding example of how I would apply uh, this four-step framework on solving an open source problem. So let me just share my screen. Okay, so for example, the problem that I'm trying to solve is that uh, the stable diffusion models, these models do not cannot understand the scientific names of a flower. So for example, uh, this is an example of flower. The scientific name of this flower is Nepenthes raja or Ginkgo biloba or Drosera angelica. So if you prompt the stable diffusion model by default, it will not be able to understand what this scientific name means. So the first step would be how I created this data set for captioning. So either I need to create this data set manually or I need to write a script to create a synthetic data set. So I simply wrote a script to create a synthetic data set. So there is a Pixabay, a website where you can request images based on the name of anything. So you can get a free API key for Pixabay, and simply I gathered the scientific names of around 20 flowers. So Stable Diffusion Excel by default does not understand the scientific name of these flowers. So I gathered these 20 names, and I simply wrote a short script to just extract all these images. So now I have around 4 images per flower class, so it is around 100 images. But I also need a good prompt for this dataset. So the way you can create, so the way I created the prompt in this case was, uh, so this is the default view of flower images. So this is the just an image and the class name. So I don't have a prompt for this image. So what I simply did is I used a model known as Blip. So I knew about this model. What Blip does is it simply write the caption for that image. So you can use this model or you can use any other model. Uh, so I simply wrote a short script which actually helped me create this script. So here you can see that now I have changed here. Now I have changed my class's name to a small uh, prompt. So a small caption. So now you can see the caption of the first image is a picture of flower on a black background. So we have also have the spatial information. The type of flower is the scientific name of that flower, or a picture of flower with a small flower on it. So there are two flowers here, and the type of flower is the scientific name of that flower. So in this way, you can create a data set. Either you need to find an available data set, you need to write a script to create synthetic data set, or the third step would be that you need to create the data set manually. You need to manually capture the images, manually label them. And you can do all of these, but since these days the foundation models are so good that you can use another model to create data sets for another model. And this is how most of the work is done these days in open source. So you take another model, you create a data set for another model, and then fine tune it. So now when I have these 100 images, I used Hugging Face to fine tune. Uh, so first of all, I pushed this data set to Hugging Face. So uh, you can see this data set here. You can see this data set here. So I pushed this data set on Hugging Face. So now this data set is on my profile. It is an open source contribution, and you can contribute anything, any data set to Hugging Face. So it is a very valuable contribution. The data sets contribution. A lot of people use your data sets. I can show you another data set that I created synthetically for large language model. So this is a dataset that actually contains multiple languages. So it has Bangla, Urdu, English, and French, Arabic. So it has 5 to 6 languages, and it is a big data set. And I actually created this data set synthetically. So there are multiple ways you can do a Google search on how you can create a data set synthetically. But essentially, the idea is that you need to take another model, create the data set for another model, and this is the simplest way. And you can simply push that data set to Hugging Face, and it is really simple. uh, you have to use the Hugging Face datasets library, create the dataset, and push it to your Hugging Face folder. So so you can see that. Now if you want to fine tune the dataset, I again use the stable diffusion Excel model from Hugging Face and fine-tuned it using Accelerate from Hugging Face. And now, as a result, I got a model that was actually able to understand the flower's name in the scientific way. So now, if I compare the results, so this was the original prompt towards stable diffusion model. A picture of a red flower in front of mountain type of flower is ginkgo biloba. So it has to create a red flower, but the flower has to be of this scientific class, Ginkgo biloba. So a waste model which was not fine-tuned for it was actually not able to do it. And we solved this problem by fine-tuning it and creating a new data set. And you can see the results here. And you can actually compare all the classes, and you can see that this is actually the Coryanthes speciosa flower, which was not being able to create by the base model. So if you can understand the idea of uh, this the idea of the framework, the first step framework is that you need to find a problem that is not solved or no one has thought about that problem. You need to solve that problem either by creating a new data set or creating a new model or uh, using existing models, and then you need to publish your results. You need to so I published this model as well on Hugging Face. So this is the model on Hugging Face, and it is a very simple model. Yet it was downloaded 12 times last month, which is I never thought anyone would download this model as well, but someone actually downloaded this model, and I haven't added a lot of details here, but it is actually this is the place, this is the readme of your Hugging Face, and you need to write what you have to what is being done in this model. So this is actually a four-step process that you can use as a beginner, and I think it is anyone can achieve this. You just need to think about a problem. You need to play around with the model first. So if you want to find the models where you can find a model, you need to go to huggingface.co/model. So you can see that on Hugging Face there are more than 10 lakh models on Hugging Face available, and it is a huge number of models. So you can find all sorts of models. So you can filter the models from here. So you can see image to image, text to text, image text to text, visual questioning answering, document questioning answering. If you want to see about computer vision, depth estimation, object detection, image to text, image to video, video classification. Then there are NLP models, text classification, token classification, zero shot classification. Then you have audio models, you have tabular model. There are even reinforcement learning and robotics model, graph machine learning model. So whatever is your research interest, or whatever field interests you in AI, you can find the models on Hugging Face. If you want to use the model based off a specific library, so you can even filter by library. So for example, you want to contribute to a model that was actually based on TensorFlow. So you can find all these models that were created on TensorFlow here, or you can find all the models that were created using JAX here. So you can filter based on all these. You can also find currently existing data sets. So either you take a model from here, then you find a data set from here, you can fine tune that and see the results. But the idea is that you need to understand uh, how a model works, what are the shortcomings, and how you can improve those shortcomings, or how you can actually solve a problem using that model. And then you need to write an article on uh, Medium or anywhere. So even a good Hugging Face README or good GitHub README is good. But I think it is also important that as a beginner you should write more about what you have done, so that you can understand how things work. All right. So now I will talk a little bit more about how you can. So, so this first step was for beginners. So how you can get started in contributing to open source as a beginner. So as a beginner, you need to contribute more and more projects, more and more data sets, more and more small problems. But now, if you want to take it to a next level, how you can do it? And I think everyone should try to take their contributions to next level. So how it works in machine learning community these days is that there are several different communities. There are a lot of different communities that are present and that actually actively accept new contributors. And what they do is that they try to choose a big problem and they solve that big problem on a bigger scale. So, for example, I'm showing you these four research papers here. These and all of these four are actually open source libraries which are very famously accepted by people. So GPT-Neo X20B, it was created in 2021, and it was one of the biggest competitors of OpenAI GPT-3, which was closed source. And what they did here is that they actually simply gathered these contributors at eluther.ai, and they said that they will create an open source model that counters GPT-3 or is on the performance of GPT-3. So these are all the contributors you can see in the top right image. Sid Black, Stella, Eric, and all of these contributors. And these are from multiple institutions. So some of them are from Eluther.ai, some of them are from Melta, some of them are from different universities. So if you get involved in these community research projects, you will actually contribute something that is used by multiple people on a daily basis, as well as you will publish a research paper that is actually uh, uh, accepted by peer-reviewed journals or peer-reviewed conference, and you will get to uh, collaborate with all of these different people from big institutes such as Meta, Google, Georgia Tech, or big universities uh, such as UC Berkeley. So I will talk about 3 or 4 different communities on how you can join those communities, how you can get involved in these types of projects, and how you can actually take your open source contributions to a next level. So I'll just go back to my browser here, and I'll talk. So first of all, I'll talk about Eluther.ai. So the idea of Eluther.ai uh, with started with the idea that a lot of the current state-of-the-art models are closed source. So we should create open source alternatives for them. So all of the research that has been done at open source is actually uh, all of the research that has been done at Ether.ai is actually open source, and they publish very high quality research papers for them. So, for example, uh, these recent research projects, they focus on AI alignment and interpretability. So, if you want to understand how uh, language model actually work inside, how the neurons of language models work, so they create these sparse autoencoders to understand how these language models work and stuff like that. So you can simply join it by clicking here. So you will go to their Discord, and you will see. So if I go to my Discord, I can open the Luther.ai Discord here. And in the Luther.ai Discord, you can see a lot of stuff happening. So it is difficult. So the problem here is that it is difficult to join a current project because it is not very well organized. But you can find, if you stay consistent here, you can find a lot of opportunities to actually contribute in community projects. So this is the community projects tab. You can see all of these projects that are ongoing here. So for example, RWKV6, it was one of the latest LLMs that is not based on GPT. It is a new architecture, and it was introduced by Eluther.ai. So you can find all of these projects that are ongoing here, as well as you can find projects in these tabs here. So for example, GPT NeoX, you can find all the latest development of GPT NeoX here. So the idea here is that you need to simply jump into the conversation, and you need to ask them that you want to contribute. So for example, you can see that this person is very active here. You have to reach him on a private message, and you have to tell him that you want to contribute to this project, and what are the current open tasks or current things that you can do. And you should reach out to multiple people, because a lot of people here gets a lot of messages that they might not respond. So you should reach out to multiple different people who are active in these repos. So you can find research leads here. You can find regulars who contribute regularly. So you simply need to reach out to these people, and you need to ask about uh, getting involved in this project. And this is one of the ways that you can publish high quality research. You can publish high quality code. So if you go to the code repos of Eluther.ai, so if I go to GPT NeoX, it has been start 6.9K time, and it is still active. So for example, the last commit here was yesterday. So still people are actively developing kind of this model GPT UX and improving it. So, and a lot of and if you see the authors here in the slides, you can see all of these authors are from different institutes. Some of them are independent researchers like you, or are from different institutes who are collaborating officially. So that was Eluther.ai, and the idea is that you need to jump into Discord and get yourself engaged because uh, it is difficult to do it in a systematic way. You just need to jump in and start contributing. Now I'll talk about Lion. So Lion is also uh, another community, open source community, which is based on Discord as well, and it is very similar to Eluther.ai, and they have a lot of different projects ongoing. So you can see all of these projects. They are databases, there are models, uh, different types of tools, research papers. So for example, this Lion 5B on the bottom right, it is one of the most famous datasets to train stable diffusion. In fact, this dataset was used to actually train stable diffusion 1.5. So these type of contributions are done by the communities, and you can see the institutes such as UC Berkeley, TU Darmstadt, University of Washington, and all these big names that are actually contributing to these projects. And you can have your name here as well if you contribute enough to these projects. The idea is also similar. You need to go to this link and you need to join the Discord. Uh, at Lion, joining new projects is relatively easy. So this Christoph is the main person at Lion who actually runs Lion. And he used to be a school teacher and he made the transition into AI, and he actually became one of the biggest open source contributors towards AI in the world. And he actually posts on a regular basis about open tasks. So you need to keep an eye on this channel of open tasks, and then you need to get involved in any project here, and you simply help them create this project and publish the code, publish the research paper, and everything which is used for trend. And you can also find a lot of other channels here which are actually active or might not be that active, but a lot of these channels have been used for creating new projects. So, so you can explore lion.ai, and you can explore how you can contribute to these projects. Uh, And lastly, I also want to talk about Cohere for AI. So Cohere for AI, at Cohere for AI, you will not probably find as many projects as you can find on Elytra or Lion. But Cohere regularly at Cohere regularly there are some some expeditions or some sort of small mini project. So for example, this was a Cohere for AI's Expedition Aya. The idea of Expedition Aya was that it was a 6 week worldwide open build challenge, and Cohere provided with the API and all the compute credits that you would need. And there were multiple different projects that you can see here, which in which a lot of people participated. So, for example, uh, this project, Multilingual Climate Chatbot, was the gold prize winner. Evaluating reward models in multilingual settings, it won silver prize. Someone created a Aya model, a language model for Sanskrit language, and it won bronze model. Then someone converted that Aya model, which is LLM for multiple languages, to multi-model. So it was the most promising prize. And then you can see all the different type of projects here. And I was part of this Aya. So we created an Aya version which is actually small and can be contributed to, can be used towards deployment. So generally LLMs are really big in size, and we want to create such LLMs that are actually that do not take a lot of memory and a lot of compute power. So we contributed a few different models here. You can see our pruning pipelines, our distillation pipeline. Uh, but the idea is that you need to get involved with any of these communities, and uh, you need to start contributing to bigger projects. Once you have some experience with smaller projects, you should take it to another level, join these communities, get yourself involved, and contribute towards the project that actually are used by thousands of millions of different people. So next I'll talk about the compute power. So as you all know that we need a lot of compute power for open source machine learning. And I think the easiest way for anyone to get this compute power is Google Colab. So Google Colab gives you a free T4 TPU, which has 16 GB VRAM. So it is not suitable for bigger projects or bigger language model, but you can run smaller models like Polygamma or other small computer vision NLP models on Google Colab. It has a smaller runtime, but it is good for small projects. Then Kaggle also provides two T4, so it gives you multiple GPUs, so you can use the power of distributed training for this, which can actually help improve your training speed by a big factor. And it is also good for small projects, and the good thing is that it has a longer runtime, so you can run your Kaggle notebook for 30 hours in a week. So if your model needs to be trained for 30 hours in a week, you can use Kaggle. And then the last thing that I want to talk about is ML Collective. ML Collective is actually another community that is very similar to the previous community that we have talked about, but it has one of the very important things here. It has MLC compute assistance. So, so the idea here is that you need to create a project proposal, that what is the project that you want to work on, what is the problem that you want to solve on. Can you publish that problem as a research paper, which we have talked about in the last two Lion and Luther, uh, and what are some of the uh, things that you will be using, what are some of the models, some of the data sets that you will be using. And if this proposal is good enough, they will give you a Google Cloud account. So you will have around $1,000 or $500 per month limit, where you can create any instance of your choice, or you can use Vertex AI or whatever you want for that $1,000. So if you want, for example, A100 GPUs which are used for LLM, you can create those instances and train your model. So it is one of the very important community contribution that has been done by MLC, and this compute is really helpful to train models that are on larger scale as compared to uh, Colab and Kaggle. So uh, you can also find the ML Collective Discord here. Since you go to the home here, you can find the Discord of ML Collective somewhere. I'm not sure where it is, but you will find it somewhere here. And then they also have, if you don't know what idea to contribute, they have these regular research jams. You should attend these research jams, and you can get involved with one of the projects that someone else is working on. So I think it is very important for someone who wants to contribute to open source research. You should get involved with these research jams. And then if you are looking for mentorship, if you want to get mentored by someone who is really highly accomplished, you should come to these machine learning office hours. You can simply book a time from here, and you can have one-on-one meeting with all of these professors or uh, people that work at Google. So, for example, this guy works at Google. He works at Allen AI. He also works at Google. So you can book a time from here in their calendar, and you can talk one on one with these people to actually understand how how you should move forward in your career. Uh, Most of them are focused on AI research because they work at Google or they are professors, but it can actually be really helpful to uh, progress your career if you book a time with them. And if you are applying for grad schools, you can. So they used to have this grad school application help session. I'm not sure they are active now, but you can book a time from here, and it is very helpful. So if you, for example, if I click here, I will be going to the calendar, and I can choose any date from the calendar that is free. So for example, I can book a session for 17th November and I can talk one-on-one with Ayush, and he is happy to mentor newcomers in computer vision, robotics, and machine learning. And he is actually, I think, professor or PhD student at CMU, which is a Carnegie Mellon University, and it is a really top school uh, in the world. And lastly, yeah, so if I would like to summarize this talk, the idea is that you need to find a model, you need to understand the model, then you need to find a problem, shortcoming. You need to create a data set for that problem. If you want to, you can create synthetic data set, you can manually label that data set. So for example, I used 100 images. So it is easier to label 100 images manually. It's not like a very difficult thing. It might take 2 to 3 hours of your time, or maybe a little bit more, to manually label these 100 images. And if there are more, then you can create them synthetically. Then you need to solve that problem, fine tune the model, create a new model, or anything, any way you would like to solve the model. You should publish that model and dataset on GitHub and Hugging Face as well, so that your Hugging Face profile is not empty. And it is really important to have a good Hugging Face profile. And then you need to publish the results as a blog on Medium, or on any place, any blogging site that you like. And once you are a little bit proficient in it, you should move your open source contribution to a next level, get involved with communities that do impactful research, get involved with communities like Elitra.ai, Lion, ML Collective, Cohere for AI, and then participate in their project and publish research paper, publish open source work, and these works are used by thousands of people. Uh, so you will be actually working on something that is used by a lot of people on a daily basis. And if you want to stay ahead of curve, so if you want to, one of the things that make open source contributions famous these days is that you try something on a newer model that has not been tried before. So, for example, a lot of people might have tried, maybe let's say, the scientific flower problem on stable diffusion. But as soon as a newer model like Flux has arrived, you should try that problem with the newer model. So, if you want to see how, if you want to keep an eye on newer models, you should follow Hassan Khalik. He works at Hugging Face, and he posts mostly on Twitter, but also on LinkedIn as well. And he also has this Hugging Face daily papers page. So you should follow. Uh, if you go to Hugging Face daily papers here, you can find all of these daily papers here. So, for example, if you want to uh, so someone released this dataset called World Cuisines, and you want to try if this dataset actually covers the cuisines that are in Pakistan, or the models that are fine-tuned on this world cuisine can actually understand Pakistani cuisines, or so you should try that. So now you have a problem, you try to solve that problem, and you actually publish that as a blog or something like that. And now, interesting thing about this paper is that it is also something that has been done on Discord. So you can see all of these contributors. Uh, if I open the archive of, so you can see all of these contributors here from multiple different institutes. So there are people from C Crowd, University of Toronto, KAIST, Cardiff University. There are independent collaborators. There are collaborators from Boston University, Columbia University, Cohere. So these works of these sorts are actually done on Discord. So someone had the idea, they proposed it on a community channel. They gathered all of these contributors from different places of the world. Some of them are independent, like they are not affiliated with anyone. They contributed this data set and then they published the data set on Hugging Face. You can find it somewhere on Hugging Face, and you can actually see how it actually how different types of models performs on these. So you can actually use the data set and see how it works with the Pakistani cuisines or whatever. But the idea is that you need to see what are the latest models that are being contributed on a regular basis, and you can find them from here. All the good models that are or good papers that are published daily. So you can just simply get this daily papers, and it is contributed by Hassan Khalik, who works at Hugging Face. And you can also see the daily papers at archive. So every day around 40 to 50 new papers are submitted on cs.cv on archive, and you can see the papers and see what type of work is actually going on in the field of AI. So yes, that's all from my side. If you have any questions, I'll be happy to answer. Thank you. Okay. There's not a fixed set of prerequisites. So for example, you know, if you know the basics of Python, basics of machine learning, uh, the idea is that you need to get started with a project and you need to publish that project. So, for example, if you know the basics of machine learning, if you know the basics of Python, you should get started with a project. So, for example, if you want to work in the field of LLM, and you take a small language model that you can run on Google Colab, and you play with that model, and you actually found that that model cannot work really well on a specific set of poetry or a specific set of, let's say, the model cannot understand uh, some big famous writer like Shakespeare or whatever. So you actually had to find that problem. Then you need to create data set for that problem. So now how you can create that data set, you take a bigger model. So for example, you use OpenAI GPT-3 or GPT-4, and you create a data set using that model, because that model understands that problem. Now you have some data set, you use that data set to fine tune the smaller model, and you can have a smaller model that actually solves that problem. Now you need to write a blog paper on that. You need to publish your data set and on the GitHub and Hugging Face. So you don't, so there are not like a fixed set of prerequisites, but ideally you should have basic knowledge of Python, basic knowledge of machine learning and deep learning, and then you should simply get started with projects. Yes, Salim, you can unmute and ask the question. Sorry, I was not able to hear you. Can you repeat? No, you can start without industry experience as well. So, for example, if you are a student, you have basic knowledge of Python and machine learning, you should just play around with the model. You should find a problem. You should solve that problem, and you should publish that. So, at a beginner level, you do not need to have some industry experience to get started. You can get started in open source without that. Yes, you can unmute and ask the question. Uh, it depends on the university requirement, but I think if you do a project that is like on a bigger scale, but you can definitely use that project as a university final year project. And so, for example, uh, I think the final year project has a little bit more requirements. So, for example, you need to have some sort of UI UX as well. You need to deploy it somewhere. You need to add you need to create more of a project that is end to end. So you can essentially use the idea from here, the model idea from these, and then you can integrate that model in your final year project pipeline. Or if even if it is a research based project, so then you can probably focus only on the model. So if you are doing a thesis in your undergrad, you can just simply focus on the model aspect and solve that bigger problem uh, using the model.